Hello, Math 95 students. Fall term, boring jump start for the first 2 weeks. You guys have had not much to do, so here's something for you to do. I'm going to switch over to share my desktop. And take a look. That pre-test y'all took with me, thank you for doing that. Just to kind of warm up to the material that you hopefully remember from a previous math course. Here are the average percent correct. So each of these topics had 4 questions, and the solving linear equations, that's an important one. That one went really well. That was good to see. Playing with formulas and simplification. I was kind of surprised that the simplifying expressions didn't go well. We'll review a little of that today. Equations of lines, systems of equations went really bad. Fortunately, we don't need that immediately. The most important things for me right now are item 3 here, which is good. And then most of what we do this term is going to be based on these 2 sections here. So I'm going to show you some places you can brush up on that right now. So here's our course in Canvas, and I have this big old review section for anyone that wants to brush up on stuff. Remember, you can minimize these sections and then expand them. So just about everything on that pretest is in one of these review sections. Each review section has a bit of a textbook and some homework problems and some videos. So we're going to jump down to review section 3. I'd highly recommend reviewing properties of exponents. I'm going to jump into polynomial stuff because that's what went the worst. So here's a textbook selection. Here are some videos. I'm going to take a peek at some homework problems. And you should get logged into My Open Math once you log in the first time. After that, it just remembers who you are. So some things to remember about polynomials. So let's grab this sucker right here. Put it in my whiteboard. And a lot of problems had video help that you can get to. So degree of a polynomial, that is the highest power of the entire polynomial. So this last question down here is asking about the degree. Highest power I see here is the 4th power. So I would say this is the 4th degree polynomial. When talking about the leading term, you want them to be in order. So really I should write this as negative x to the 4th plus 5x cubed plus x squared plus 3x plus 3. So we usually write things in descending order by the power. So there's a 4th degree polynomial. It has 5 terms. The leading coefficient is the number multiplied by the x to the 4th. Well, a negative is really a negative 1 time. So the leading coefficient would be -1. But we want to know the degree of the leading term. So I put that in the wrong spot. Scratch that. Some other things to consider. Each term has a degree. So in this case, the first term is the x squared. Its degree is 2. Its coefficient is 1. The second term here has degree 3. Its coefficient is 5. The 5th term is going to jump down there to this one right here. It is degree 4, and it has a coefficient of -1. So we have coefficients for terms in polynomial. A term is just a part of a polynomial. So term is something that's part of an addition or subtraction problem. All right. Let's take a look at a different problem. Find something more exciting. All right, addition. Yeah, that's not too bad. We'll try that sucker. Let's blow it up. Steal it. Or clip it, I should say. So we want to simplify this. Ooh, I grabbed the wrong thing there. How did that happen? Try that again. There we go. So we want to add these 2 polynomials together, and the parentheses on either one really are not necessary, so I can do without it. So I can say this is just 4x cubed plus 2x squared minus 7x plus 1, and I'm adding on a 4x cubed and an 8x squared and a 9x minus 3. And then it's just a matter of identifying like terms. So for example, these cubes are like, and oops, that's supposed to be a square there, isn't it? There we go. The squared terms are like, so those get to be added up. And these linear terms, and then the 0 power ones get to add up. So when I put all that together, I have altogether 8 of those x cubes. 2 and 8 means I'll have 10 of the x squareds. I'm losing 7 x's but gaining 9, so altogether I have 2 x's. Have 1, I lost 3, so I'm going to have a minus 2. So that would be the sum of those two there. Subtraction's a little trickier, but not much. I bet the next homework problem is a subtraction. Nice. So let's screenshot that one. See what we can do with it. Now the trick here is in algebra, subtraction is really adding the opposite. And opposite is really multiplication by -1, so that means the subtraction sign needs to get distributed through. So what I really have to do here is take my negative 9x to the 5th, minus a 4x squared minus 10x, and then I'm adding a negative 9x to the 5th, so I'll say that's a minus 9x to the 5th. And then I also have to bring that over here, so it's a minus x squared and a minus 3. So the bottom line is you got to distribute that negative through. Once you do that, it's like the previous problem, just start combining like terms. So in this case, these guys are like. I have negative 9x to the 5th. I have another negative 9x to the 5th, so that's negative 18 x to the 5th. X squareds, we have a minus 4 and a minus 1, so that's going to be minus 5x squared. There's no other x term here, so I have a minus 10x, and then the minus 3 would be the result there. All right, recommend practicing some of those. Let's jump to the next section. And all right, so that was addition down here somewhere. Let's take a look at multiplication. So there's some good practice problems you can do here. I'm going to jump down to this one right here. So here, it just involves using the distributive property repeatedly. Oops. So if this was just 4x times this polynomial, I would distribute the 4x through, and that would give me 4 times 2 is 8x squared plus 4x. But I also have to distribute that positive 4. So that will give me an 8x plus 4. Sometimes you get like terms, so I could rewrite this as 8x squared. So let's see, 4 and 8 is 12 x's, and then plus 4. If you're ever unsure that you did it right, the only way to check a problem like this is by evaluating. Pick a number for x, plug it in here, like maybe x equals 2. Pick the same number for x, plug it in here, and see if you get the same answer. Calculator can help to check that. Otherwise, you can just try to redo it without looking. Let's see if there's any more interesting ones here. Oh, not too bad, not too bad. Not too bad. Ooh, doing 3 of them. Let's try that one. Just like when you multiply regular numbers, we can only multiply 2 things at a time. So we just have to take this one step at a time. The order in which you multiply doesn't matter. So you could, for example, choose to multiply these 2 together and then multiply by the 5x after. So I'm going to take that route. So I'm going to distribute the 2x through first. So that's going to give me 2x squared minus 10x. And then I distribute the 3. That's going to give me what, plus 3x minus 15. Now, all of that still has to be multiplied by that 5x. Before I do that, though, I'm going to add those 2 like terms. So eventually, I'll take that 5x times 2x squared minus 7x minus 15. Now for that last part, distributing the 5x through, 5 times 5 is 10, x times x squared is x cubed, minus 35 x squared minus, what's that, 50, 75 x. So that would be the final answer. Just for fun, I'll show it doesn't matter which order you multiply. So I could choose to multiply these two together first, in which case the 5x only goes to those terms, and that will give me 10x squared plus 15x. Now I can bring down the other factor of x minus 5, and then I have my double distribution here. First, we distribute the 10x squared. 10x squared times x would be 10x cubed, and then minus 50x squared, and then multiplying there and here, we'll have a plus 15x squared. 15 times 5 is 75 minus 75x. Like terms in the middle, 10x cubed minus, let's see, 35x squared minus 75, and then we pray they match. Going back a page, same exact problem. Okay. Next, let's jump into division. And if you want to sample everything, there's a challenge for the whole review module there, if you want to take it. All right, so we might as well, let's see, that one's easy, a little too easy. This one looks more exciting. Okay, so here, the whole polynomial on the top is being divided. That means each and every term is being divided. Let's pull that up a little more. So I can rewrite that as negative 3x to the 6th over 3x squared and 12x cubed over 3x squared minus a 6x squared over 3x squared. Okay. Then I can start simplifying each of these monomial divisions. So in this case, what do we have? 3 goes into 3 once each, and the x squared covers 2 of those. So that's going to go in there, leave the x to the 4th behind. So I'll have a negative x to the 4th from the first term. 3 goes into 12 4 times, x squared goes into x cubed x times. Here, the x squareds cancel, 3 goes into 6 twice, and so that should be the result of that division. So dividing by a monomial is just canceling repeatedly for each piece of the top, each term in the top. If it's a binomial on the bottom, then it's a little trickier. So let's find one of those. Then you have to do long division or synthetic division. So I'll do long division on this one. So it doesn't work here to try and divide each of these pieces in the top by x plus 3 because the plus in the bottom stands in the way. So just like taking, for example, 13 into 167, we can take x plus 3 into x squared plus 6x plus 17. And it works kind of the same way. If I was going to take 13 in here, I would say, well, there's 13 going to 1. Nope. There's 13 going to 16. Yep, it goes in once. 1 times 13 is 13. Subtract, bring down the remainder, try again. Does 13 go into 3? No, but it goes into 37. How many times? Let's see, twice, but not 3 times. 2 times 13 is 26. Subtract, and I get an 11, which is less than 13. So what I found is that 167 divided by 13 is equal to 12 and 11/13. So we're going to do the exact same thing here, but we have some variables to worry about. The key with this is to just focus on the leading coefficients as you do that. And so I ask myself, does x go into x squared? And I would say, yeah, it does x times. Now, I like to line up like terms. X times x is x squared. And our goal is to annihilate one term at a time. But I also have to distribute that x to the plus 3. X times plus 3 is a plus 3x. That's supposed to be an x. Now, the next thing is we have to subtract. I have to subtract the whole thing, which means I have to change the signs of each of these guys in order to subtract. X squared minus x squared gives me a 0, which is always the goal. And then I have a 6x plus negative 3x, which is a positive 3x. Bring down the next piece. Oops, 7. Then I look at this and that. How are they different? Well, I need to multiply by 3. So I make a note up here. I need to multiply by a positive 3, not a negative 3, but a positive 3. 3 times x plus 3 is 3x plus 9. Now we subtract by adding the opposite. So go through and change those signs and then come down. That term disappears. 17 minus 9 gives me what? 8. So that's my remainder. So this quotient right here, I found that x plus 3 goes in there, x plus 3 times, and there is a remainder of 8 out of the divisor, x plus 3. So just a note on some of these things here. This number here is the divisor. This number up here is the quotient. And this number down here is the remainder. And the answer of a division is always the quotient plus the remainder over the divisor. All right, that's it for now. Hope to see you soon. Get warmed up for math class. We officially start on the 9th. Have a good day. Do good math and other good deeds. Bye-bye.